Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You start by preparing the TGA dataset and verifying calibration. Load mass versus temperature data with consistent sampling intervals. This avoids jagged plots. Once done, trim any preheating baseline and correct for empty pan drift so your mass axis reflects only sample changes. Make sure to record metadata: sample mass, atmosphere, and heating rate, because they explain why curves shift. You'll need clean, labeled data to proceed reliably. Without that, later smoothing and derivative steps become misleading and error-prone. Next, you plot the raw mass percent against temperature and visually inspect for noise or spikes. Apply a mild Savitsky-Gale smooth, second order with a 7 to 11 point window, to preserve peak shapes while lowering random noise. Once smoothed, compute the derivative DTG to reveal mass loss rates. Derivative peaks mark decomposition steps and precise peak temperatures. As you compare raw, smoothed, and DTG traces, make sure axis scaling is consistent so relative amplitudes and onset points remain interpretable. Finally, you annotate the graph with onset, peak, and end-set temperatures and label percent mass loss for each step, because those numbers convey material behavior. Add a legend noting atmosphere, heating rate, sample mass, and smoothing or derivative parameters so others can reproduce your processing. Make sure axis ticks, fonts, and colors remain readable at publication size. If something looks off, inspect raw traces and revisit baseline correction. Often a baseline drift or incorrect smoothing causes misleading peaks. Fix that, then re-export.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.